Hey, what's up guys? Jake with Legacy 4x4 here again, and today we're going to be working on a accoutrement or an accessory for my Prusa Mark III's 3D printer. So today I want to build a printer filament dryer box / storage box, whatever you want to call it. So let's go ahead and get started. To do this video we are going to be using a couple of our tools to include the 3D printer is going to be making some parts for this project, as well as the new Omtech laser cutter / engraver. So anyways, with that said, let's go and get started. Okay, so as you can see here in the new shop, I have my Prusa 3D printer, which is sitting on top of a newly acquired Husky tool chest. So I got the tool chest to put the 3D printer on, put my computer for the laser on, and then store random laser things and 3D printer parts, etc., etc. And also to store tools in it, because that's what tool chests are for. Now, in addition to that, I have the 3D printer, which I do have the Prusa enclosure for on this as well, which keeps the printer, like you can see, the top of it has dust all over it, but the printer itself is very clean, which is why I wanted to have an enclosure for the printer. Now, in addition to that, I do also want to have an enclosure for my filament. So as it stands right now, I have the filament just in one of the drawers. That's not very conducive to long-term storage of the filament, as well as it's just kind of annoying. And you can't really see what you got left, etc., etc. So we're going to build a printer filament dryer box that I'm going to set on top of the Prusa and take up some of this dead space that we have up here and use it to store 3D printer filament. And so to do that, we're going to 3D print a few parts on the Prusa itself, and then we're going to use the laser cutter to cut some things out. So let's go ahead and I will show you what parts we bought for this, what parts we're going to make for it, and I'll show you what the process looks like. Okay, so starting off with the parts that we had to buy. So the way a filament dryer box works is usually you have some kind of a heating element inside of the box itself. This is going to help to take away some of the humidity. So humidity is what actually causes a lot of 3D printer filament to go bad. It's when water seeps into the filament itself and it causes it to corrode, which then leads to a combination of things. The most of which is going to be poor print quality is the first thing you'll notice, but then secondary to that is you will start to see print failures. And I have recently, because some of my filament's a little old, because I don't use a 3D printer that much, so some of the filament is relatively old, and I have started experiencing a high rate of failure with my prints, which is what spawned me to want to make this box in the first place. So let's go ahead and go over the parts that we are going to need to complete this box, and then I'll show you guys what the assembly process looks like. So to start, for the parts that we had to buy, I did just buy all these parts on Amazon. There's not too much money, about $200-ish to build this box, which when you compare it to something comparable, such as the Rev box or Rep box, this is about half of the cost of that. And granted, you have to have the tools to use this, but you could do this by hand if you wanted to, truly. I happen to have a laser cutter, so I'm going to use my laser to cut out my panels, and then assuming you have a 3D printer, because you're building a 3D printer dryer box, you can 3D print out the bracketry. So to start with the stuff that we had to buy on Amazon, first thing is a heating element. So this is a small PTC style heating element, very, very small, couple hundred watts, I think, 200 watts actually. So this is a 110 volt AC input, 200 watt output heating element. It has a normal style plug on it that will just be able to plug into a power strip. So we've got one of these for a few bucks. In addition to that, I did buy a bag of like desiccant, which is like your air filtration dryer stuff. It's similar to like what you would have inside pretty much anything you buy, which is going to have some kind of a desiccant material in it, be it silicone gel or whatever. So this is just got a bag of that so I can replace them inside the box over time. I had to buy your assortments of hardware, so I got two different sizes of 1/4 inch by 20 bolts, and then just an assortment of 1/4 by 20 nuts. I picked up two of these temperature and humidity sensors, which are actually very similar to the ones that is on my Prusa enclosure itself. So I got two more of these. I'm going to put them on the box as well to monitor temperature and humidity from inside that box. Got some small acrylic hinges, but these are adhesive hinges, so these will just adhere onto the frame as we build it. So we got a handful of those. And then lastly, you can see it on the table, we have an assortment of acrylic. So for this box, I'm mostly going to make this out of 1/8 inch acrylic. I chose that material because it's lightweight, it's easy to work with, and I can use the laser cutter to cut out the panels to the right size, and I don't have to turn on any of the bigger tools. It's just quick and easy using the laser cutter. And the last thing I almost forgot, I got some 1/2-inch aluminum solid rods on Amazon as well. Those are going to make the bars that the 3D printer filament actually sits on. Alright, so that covers all of the materials we had to buy, which again was a couple $100, about $180, $200 or so dollars shipped to my house. For materials that we 3D printed, I printed out 4 of these little rod holders that you can see here. So these are just small little brackets that are going to hold these metal rods. I printed out some corner braces for the box itself. There's a part of it that's angled, so we have some angled corner braces, and then we have some long, basically angle iron looking piece corner braces as well. They're going to be for the long portions of it to give this a lot of rigidity. And we have a handle for our box and some feet for it, so it's got nice feet to rest on. So those are the parts we printed out. In total, it took about 20 hours of printing to print out those boxes, or those parts. I did not record any of the 3D printing because 3D printing is frankly kind of boring to watch, especially on a YouTube video. So I didn't record any of the 3D printing, but what I will show you right now is the laser as we laser out these acrylic panels, and I'll show you guys how the Omtech laser works. So let's get to cutting out these panels and then we'll get into assembly. So moving over to the laser here, as you can see, I have a piece of sacrificial board down here, and normally you wouldn't need this. There is a plate down here. However, I was cutting out some flasks, something that Matt and I are selling on Amazon now. So I was cutting out some flask on this, and so I have the flash jig below this. So I just put this sacrificial piece on top of it so that I don't ruin the flash jig, and so I can cut these out without having to move the flash jig around and take it out and stuff. Anyways, I have our piece of acrylic here. This is a piece of 1/8-inch black acrylic, and I'm going to be using that to make the bulk of this box. So for it, I already know, because I've done this a couple times now, I know where it needs to sit on the laser in order to engrave, but on Lightburn you can frame it out if you need to verify that it's going to fit in your cut area. I drew up the designs previously on SolidWorks, so I've got them all done, and now I'm just going to cut them out over here, but you can see this is what the laser looks like to be set up. And moving over to Lightburn, I know a computer screen is hard to see on the camera, but I've got the different drawings in here pulled from SolidWorks, transferred to DXF, and then loaded up into Lightburn. So I've got that board up. I'm going to go ahead and just click start and let that run. Okay, so some of you guys might have seen some shorts about this laser when I picked it up a couple of weeks ago, or about 6 or 7 weeks ago. So I recently picked up an Omtech 60-watt CO2 laser, and I've been using it a ton recently on a lot of different projects. It's really nice to have a strong laser that I can use to quickly cut through projects like this, to do engraving and marking and things like that. So it has been a really useful tool in the shop. I upgraded from my original, my small scale laser, and I just went ahead and went up to a larger kind of industrial style laser. I also have a VEVAR water chiller next to it that cools the water that goes into the laser to keep the laser functioning nice and cleanly. I've been using this laser a lot. Like I mentioned earlier, Matt and I are expanding what we do as a business, and so we are opening up an Amazon storefront. We're going to sell Heim joints, some specialty bolts, and a few other off-road related parts. But in addition to that, as being part of a veteran-owned company where Matt and I have both served in the military and I am still serving in the military, we wanted to also extend it out to a few custom military related parts. So for now we have some 8-ounce metal flasks that you can buy on Amazon that have different military organizations on it, and different badges and tabs and things that you can get in the Army. And then in addition to that, we're going to eventually expand that out to doing like coasters and a bunch of other stuff too. So if you're looking for that kind of stuff, you can go to Amazon. You can buy those things from Amazon. And then if you have a large order, if you're like working for a unit or something like that and you want to do a large order of something, feel free to reach out, and I will do large custom orders per request. So anyways, that's that. That's why I have the laser. I got it for my own personal use, but then I'm going to expand it out and use it for some of my business uses as well. So anyways, I'm going to sit here and I'm going to cut out all of these parts. As you can see, the laser is currently going. And bringing you guys over here, it's kind of hard to see, I know on camera, to see through this this film, and it's pollen season in North Carolina, and I keep the door open, so we got some dirt and stuff on here. But you can see that this is the laser working as it cuts through this acrylic. It cuts through it beautifully, makes a perfect part, and super easy to work with. So I'm gonna go ahead and sit here and cut all of these parts out. I'll show you guys the finished parts on the table, and then we'll get to our assembly. All right, so with all of these panels cut, now it's time to assemble. So this is how these panels came off of the laser cutter. As you can see, I used it to cut out and mark all of the holes, as well as to cut the panel to the specific shape of what we're building. So I'll show you guys all of these parts here in a second. I got to take the film off, so when you do acrylic, it comes with like a adhesive film applied to it, so I got to pull the film off of this last part here, and then we'll get into assembly. But for parts, we have 4. These are clear just because I happen to have some extra clear from one of the sheets that I was cutting already. These are clear. These are little support brackets for the bottom. These are the 2 side panels. I actually cut out 4 of these side panels because I'm going to double layer the side panels, and then on one layer of it I'm going to use it, or I cut my logo into it, the Legacy 4x4 logo, and then we're going to have some yellow behind it to give it a little bit of a flare, a little bit of a pop. This is the front door, also clear because it's the door. And then we have all of the assorted like main body pieces are made out of this black, shiny black acrylic that we have here. So with all those pieces cut, let's go ahead and get to assembly. I'm gonna start with the floor and then work my way up. So the floor, I'm gonna be using the slightly longer 1-inch 1/4x20 bolts, and we're going to mount our rod holders, these clear support pieces, and our feet to the floor. So let's go ahead and get to that part of the assembly first. So we actually put that together really quickly. I know it was just like one montage of me just basically assembling this, but things do come together really quickly when they're designed to do that. And so by cutting everything on the laser and 3D printing all the parts to exactly my specs, it was very simple to just put this box together. This, as you can see, is the finished box. We got a clear face on the front here, which opens up into the center compartment. And then as you can kind of see here in the center compartment, these are where those metal rods are. So the way that this basically works is this is obviously a box. It is not a completely airtight enclosure. However, it is an enclosure that will at least keep some of the moisture and other random things out of the 3D printer environment. So I could come through here and like silicone caulk all of these edges, which I might do in the future, but I don't have any of it at this moment, so I'm not gonna do it now. Relatively simple box. Up at the top here, we have the 2 humidity and temperature sensors, one on each side, so I can get an accurate reading of the entire box's temperatures. And the inside here, we have some of those metal rods cut down to be 10 inches, and that is what the filament sits on. So as you can see, I have an older roll of filament here. You just put it into the box, and you can sit it just like that. So this should hold about 6 or 7 rolls of filament inside of the box here with plenty of clearance. I did make the opening here just a little too small, so you got to kind of like twist these out at an angle. So truthfully, you won't be able to fully load this box with all like 7 or 8 rolls. It'll probably fit about 6 is what it's going to be designed to fit. But it's relatively low profile. It's got a nice clean look to it. And as you can see on this side, I even put the Legacy 4x4 logo on it, which I think looks really cool and kind of gives it a little bit of a pop. On the back of the box, we do have our heater here. So this heater gets plugged into a 110 volt AC outlet, and then it will pull air in and help heat the box here to keep the box at a nice consistent temperature. On the bottom of the box, here, which you can't really see very well, but there's those clear support bars which give some structure to the bottom of the box. It's also where those rod supports are being supported by, and then we've got little 3D printed feet on it as well to get the box up off the ground. Those rods do sit in those rod support holders that you guys saw at the start of the video, where I 3D printed those as well to hold that 1/2 inch aluminum rod stable there on the top. Overall, a relatively simple project. I'm going to put it on top of the printer where it's going to live, and then I will close out this video. Alright, so here we have it. As you guys can see, this is what it looks like sitting on top of my Prusa enclosure. So the enclosure is made out of a metal bent frame, so it's got plenty of weight or structure to support a couple rolls of filament. I was able to fit exactly 5 rolls of filament in there, given that you have to kind of tilt it a little bit. So there is definitely room for 6 total rolls, but I made this just slightly undersized. It was a design flaw, so it fits 5 in there comfortably, which is plenty. That's about all the filament I ever keep on hand anyways. So I have 1 spare roll that's almost out, that's down in the tool chest, but that's perfectly fine. Anyway, so this was a nice, easy little project. I just wanted to show you guys using some of the other tools in the shop, the kind of capabilities that those tools bring, and then how you can use those tools to manufacture stuff that you wouldn't originally think you could. So like using a laser engraver to cut acrylic to make an acrylic box for the 3D printer. You know, little things like that where you can use the same tools for multiple purposes to either generate income or to make different projects and unique ways that you can utilize your tools. I hope you guys liked this video. If you're interested in stuff like this, I will package up all the files and I will put them on the website. Either they'll be hosted through the website, or I'll just link on the website to like printables or something where you can pull up all of these files so that you can make this box on your own if that's something that you're interested in. Like I said, I hope you guys liked this video. Make sure to like, share, and subscribe. And if you have any questions, drop them down below. I'll catch you all in the next one.